So this video is all about converting from fractions to decimals. And before we can get into the actual process of converting from a fraction to a decimal form, we have to talk a little bit about fractions and decimals and why we can actually convert between them. And so in order to do that, I'm going to ask you to pause the video and take a few seconds to brainstorm some characteristics of fractions and decimals separately. And we're going to use those to compare and contrast and see what we can find out about them. So go ahead, pause the video, write down a few things you remember about fractions, a few things you remember about decimals, and then we'll be able to talk about why we can convert between them and move on after that. So pause the video, write those down, come back when you're ready to move on. So as far as fractions are concerned, a few of the things that you might remember are that we have a numerator, we have a denominator. They're often used to represent a unique part of a whole set. That's not the only thing we can use fractions to represent. Certainly improper fractions don't have that characteristic, but as far as fractions between 0 and 1, frequently that means that we're talking about a small part, a numerator, out of a complete larger set, a denominator. As far as decimals are concerned, a few things you might have remembered about them is that they're based on place value. They break down the information into tenths, hundredths, thousandths, etc. But one thing that you probably notice about both of them is that they are both used to represent parts of a whole value. Now we can have fractions and decimals that represent integer whole number values, but more often than not when we're talking about fractions and decimals as ideas, it's because we're talking about values that are between two whole numbers, between 0 and 1, between 1 and 2, between 2 and 3, between 100 and 101, representing partial numbers by using fractions and decimals. And so, for example, we know that 1/2 is the same as the decimal 0.5 because half of 1 in place value is 0.5. And it turns out that for every fraction, there is a decimal that represents it. Now, it doesn't necessarily work the other way. There are some decimals that don't have fractions, and you've probably actually heard of a few different examples of it, but we'll get to that a little bit later on during the year. But for fractions like 1/2, or for any fraction for that matter, there is a decimal that can represent the same value of it because they both are used to represent the same types of things. They both represent specific values between, let's say, 0 and 1, or any whole numbers. And one of the fundamental truths that we have in math, one of the most important processes and the important tricks that we have, is that if two things represent the same value, or two things have an equal value, we are able to convert between them. We can also put equal signs between them, but in this case, we can convert between them. This is extremely important and extremely powerful in the mathematical world. Converting between equivalent representations of the exact same value, of the exact same number, of the exact same formula, etc. And so, go ahead and pause the video and write this down because this is extremely important. And then we'll get into the process of actually converting from a fraction form to a decimal form. So the process of converting from a fraction to a decimal is based heavily on what the actual use of a fraction bar is. Now we've seen it used as 1 out of 2. We have a group of 1 out of a whole set of 2. 3/8 could be a group of 3 out of a set of 8. But when we're talking about calculations and we're doing some more complicated expression evaluating using for example, the order of operations or just more complicated formulas, the fraction bar is often and frequently used to represent divided by. So if it represents divided by in those cases, it can also represent divided by in the simplest form of a fraction. And just like when we read from top to bottom and left to right on a page, we're going to read top to bottom in this case. So 1 divided by 2. Once we talk about the fraction as 1 divided by 2, we can set that up as a division problem. And know that 1/2 is in fact equal to 0.5 and can convert that way. So using that definition of a fraction bar, that's how we convert between fractions and decimals. It's as simple as that. Divide the denominator into the numerator until the decimal either ends or repeats. And we'll talk a little bit more about those in just a second, but go ahead, pause the video, write down this process here. We'll talk about terminating and repeating decimals, and then we will see some practice problems that you can do before the end of the video. So as was mentioned in this definition without really even talking about it, there are two types of decimals that we might come across. The decimals we're used to seeing are ones called terminating decimals. It's a decimal that ends. When you divide the denominator into the numerator of a fraction, when you're converting it from fraction to decimal form, at some point your digits run out, except for zeros, and you have a remainder of 0 or a difference of 0 in the division process. At that point, the decimal ends. We could go on with zeros forever, but we don't want to because that would just be spending time that we don't need to spend because we've hit the end of the decimal digits. And that is called a terminating decimal. Go ahead, pause the video here. Write down that definition, come back, we'll see some examples of terminating decimals, an example of a fraction that converts into a terminating decimal, and then we'll move on to repeating ones. So terminating decimals, again, are those things that we're used to seeing with decimals, 0.75. Even 0.966723881 is still a terminating decimal because at some point that decimal ends. From a fraction point of view, let's look at something like 1/8. That is 1 divided by 8. Get rid of this over here so we have a little bit more room. We're not going to necessarily need that much room, but just in case. 1 divided by 8. 8 goes into 10 once. Notice the decimal point is there. 1/8 is less than 1. So we shouldn't start with 1 point. We should have a decimal that is less than 1. When we take 8 away from 10, we end up with 2 using a short division trick here. 8 goes into 20 2 times. That's 16. 20 minus 16 is 4. And 8 goes into 40 5 times. And that's it. That difference is 0. So no matter now how many times we continue dividing into the zeros, we're just going to end up with zeros. And so the only interesting decimal digits that we have are 0.125 or 125 thousandths. That is the decimal form of 1/8. That is the idea of a terminating decimal. A repeating decimal, on the other hand, is one where one or more digits begin repeating without end. And in order to truly be repeating, they must never stop. Go ahead, pause the video, write down this definition of a repeating decimal. We'll see some examples of it, how they're shown. An example of a fraction that converts into it, but then the practice problems we're going to do later are just on terminating ones. So go ahead, pause the video, write this down, come back when you are ready to see some examples and do some practice problems. So an example of a repeating decimal would be one that we get from dividing the fraction 1/3. So here, 3 goes into 10 3 times. We subtract 9, and we get a 1. Now we have a familiar idea. Well, 3 goes into 10 3 times. We subtract 9. We get a remainder, or a difference, of 1. Drop the 0. And it doesn't take very many times to realize that this process is actually never going to end. 3 will always go into 10 3 times. There will always be a difference of 1 between 10 and 9, and because we don't have any other zeros left here, we're just going to end up with continuing sets of 10, which means these 3's in the quotient are never going to stop. Now, we can't call 1/3 0.3, even 0.33, even 0.333 because it doesn't represent that those digits go on forever. So we have what we call a repeating bar, or actually technically called a vinculum, but a repeating bar is a totally fine way of determining it too. We put a bar over all of the digits that repeat. So we could also have digits repeat like 0.18 repeating. That would be 0.18181818181818, etc. forever. That's the fraction 2/11ths. But that is also an example of a repeating decimal. So that's what it means to be a repeating decimal. We're only going to look at terminating decimals for our practice problems right now. You'll see a bit more in class and probably watch a quick hit on what it means to divide into a repeating decimal. But go ahead, pause the video, convert 17/50ths and 9/16ths into decimals, come back when you're ready to see the answer, and move on. Now, for both of these, I'm not going to go through the entire division for every single calculation that we have. I'm going to give you the decimal forms. If you have questions about the divisions, you can see me in class. 17/50ths is 0.34, or 34 hundredths, which is actually an equivalent form of 17/50ths. And when we have 9/16 and we divide 16 into 9, we end up with a decimal 0.5625. Again, terminating, but 4 digits long. Go ahead, pause the video, convert 2 and 4/25ths as well as 1/8 to a decimal form, and come back when you're ready to see the answers and end the video. So 2 and 4/25ths is 2.16. That's actually the same as 2 and 1600ths. And then 1/8 we actually saw before, which was my mistake in using it earlier in the video, but it was one of the practice problems that were here. 1/8 is 0.125. So the process for converting a fraction to a decimal is simply one word: divide. Divide the denominator into the numerator. We read top to bottom, so numerator divided by denominator, until the decimal either ends or repeats.